Okay, let's look at a more challenging problem. Here we will have uh, uh, here we have 11 kilogram box sitting on an inclined surface which is rough, meaning there is friction that we cannot ignore, and the incline angle is given to be 30 degrees, and the coefficients of static friction and kinetic friction are as follows. Static friction is 0.4 denoted by a S, and kinetic friction is 0.25 denoted by a K. Now if the box is sliding down the slope as its general inclination would be, what is its acceleration? Then first and foremost, as always, we draw our free body diagram. We have the box here, and our choice of axis would be down the plane is positive x and perpendicular to the plane is positive y. What are the different forces? First and foremost, we note down that the weight is 11 times g, which is always vertically downwards. Then we have the normal reaction force from the inclined surface on the box, which is perpendicular to the plane. So let's call it N, normal force. And then when it slides down, since this is a rough surface, the box will feel the force of friction trying to stop it from sliding. Since the question already says that the box is sliding down, we can automatically consider that the friction the box feels while sliding is kinetic friction. Alright, these are the forces on the box. Now before we write down Newton's second law equations, we have to organize our forces in that all of the forces should be along the x-axis or perpendicular to the x-axis. So along the x-axis or y-axis. We see that N is in the direction of plus y, so it's in the y-axis. Fk is in the direction of minus x, so it's along the x-axis. But 11 times g, the weight, that is not along any of the axes chosen, so we have to break it down into its components. Perpendicular to the plane would be the y component, and parallel to the plane would be the x component. We know that this 11g is the weight, so the perpendicular component would be wy, the weight in the y direction, and parallel to the plane would be wx, the component of weight along the x direction. So if this is 30, then we know that this is 30, and hence wy is 11 times g cosine 30. Wx is 11 times g sine 30. Okay, now all of the forces are along either axis, hence we can go ahead and write our Newton's second law equations. Along the x-axis, our Newton's law equation is summation of f in the x direction equals m times ax. Let's say the block sides with an acceleration a, so that x direction is along the plane, so ax is just a. And let's sum the forces in the x direction. What are the forces? We have Fk pointing in the negative x direction, while Wx pointing in the positive x direction. Hence, we have a negative Fk plus a positive Wx equals m times a minus Fk. What is Wx? It is just 11 times g times sine 30. The mass is m, so let's replace m with 11 times a. Let's call this equation equation 1. In the y direction, what do we have? Summation of Fy is equal to MAY. The box is only sliding along down the plane, so it is not moving in the y direction chosen. It is not moving perpendicular to the plane. Hence, Ay is 0. Therefore, we have the summations of forces would be N in the positive y direction, Wy in the negative y direction. So N minus Wy is nothing but this 11 times g cosine 30 equals 0. So here we see that the normal force that the box feels from the surface would be 11g times cosine 30, which is equal to the y component of the box's weight. Let's call this equation 2. Now remember what our definition for friction was. Friction, specifically kinetic friction, was defined as mu kinetic times the normal force. We know mu kinetic, we know the normal force, hence we know friction. Friction then is 0.25 times normal force, which is 11g times cosine 30. Then, since you know friction, wherever you see Fk, replace Fk with this whole expression. So here we see Fk, we can plug this expression in. Let's do that. Fk is 0.25 times 11 times 9.8 times cosine 30 plus 11 times 9.8 sine 30 is equal to 11a. Divide both sides by 11, so this only has a left over and this whole side is divided by 11, and our acceleration comes out to be 2.78 meters per second squared. This would be the acceleration if the box just slides down along the slope. In the second part of the question, let's say you want to stop the box from sliding down the slope. So since its natural inclination, natural tendency would be to slide down the slope, we would need to exert an upward force along the plane to stop it from moving. Think about when something starts sliding down the stairs, which you don't want them to slide, what do? You push it upwards or you pull it upwards. Either ways, you have to exert a force to stop the thing from sliding down. This is exactly what the question is looking for. The question is looking for the minimum force that you would need to stop the box from sliding. Let's again start off with our free body diagram. Our chosen axis, let's say, is the same as before. This is the box. The weight is the same as before. W equals 11 times g. Normal force is still perpendicular, like as always, to the plane, and since its natural tendency would be to slide down, the friction is still acting against this tendency to slide. In addition to all this, we have a new force which you need to exert to stop the box from sliding down the slope. So we need to exert that force upwards. Let's call this force F me. All right. Then, like always, we break down the W's into its components. This is Wx, this is Wy. Since this is 30, this is also 30. Wx is 11g sine 30. Wy is 11g cosine 30. Now think about what this friction would be. Would it be static friction or would it be kinetic friction? Well, you are actually trying to stop the box from sliding, and we want the minimum force, the minimum magnitude of F me that would actually stop this box from sliding down the slope. Hence, the minimum force would be when the friction is already at its maximum. The friction already is high enough to stop it from moving just about. But then just to stop it from sliding, you have to exert a small amount of force to keep it there. That is what will give me my minimum force. Hence, this is static friction because the box is prevented from sliding. All right. Then we write down our Newton's laws. In the x direction, what do we have? I have F me going in the negative x direction and Fs going in the negative x direction and Wx going in the positive x direction. Therefore, my summation becomes minus Fs minus F me plus Wx is equal to Ma. Minus Fs minus F me plus Wx is 11 g sine 30. It is equal to 11 times A because mass is just 11. This is, let's say, equation 1. In the y direction, what do we have? Summation of Fy equals May. Again, there is no motion in the y direction, so this is 0. Therefore, right side is 0. What are the y forces? We have N, we have Wy, like before, nothing has changed in the y direction. So N is still equal to the y component of weight, which is 11 times g cosine 30 degrees. Let's call this equation 2. Now comes the interesting bit, which is a little bit different. How is static friction defined? Static friction is defined as a limit. Static friction is less than equal to mu static times normal. Less than or equal to. When do we use less than? When do we use equal to? Fs equal mu s times n gives you the maximum friction for this particular setup. Alright, so that is what we are after. We are after the maximum friction which, when already acting, will do its maximum part to stop the box from sliding down, such that I would have to exert the minimum amount of force to keep it from sliding down the plane. Okay, so our limiting value would be Fs maximum equal to mu s times n. What is mu s? Mu s is 0.4 and n is just this 11 g cosine 30. Alright, so then wherever you see Fs, replace it with Fs max. Here we see Fs, so just plug this in. Fs max is negative 0.4 times 11 times 9.8 cosine 30 minus F me plus 11 times 9.8 times sine 30 equal to 11 times A. Alright, now we have actually managed to stop this from sliding, hence acceleration is 0. So this whole side is 0, right? Then we add F me to both sides of the equation to solve for it. So on the left hand side F me goes away, on the right hand side we have plus F me. Therefore, solving for F me yields 16.6 newtons. This is the minimum amount of force I would need to exert on the box to stop it from sliding down the plane. Now let's look at the last part of the question. What is the question looking for? The question asks me about what is the minimum force that I would need to require or I would need to exert to slide the box up the plane. Alright, minimum force I would need to require to be able to just slide the box upward. So this is basically the opposite to what we were just doing in part B. Hence, let's start with the free body diagram again, as always. Let's first use our axis like same as before and set everything up. 30. Box, the weight as usual vertically downwards. Normal force as usual is perpendicular to the plane. And now our two forces would be, I will exert a force, let's call it F me, up along the plane to slide it upwards, and the friction will oppose the sliding, hence it will be opposite to my applied force. So F is now down along the positive x direction. The next thing we do is rearrange all of the forces such that all of the forces are in accordance with the chosen coordinate axis. So we break the weight down to align it with Wi and Wx, and this is 30. So Wi is 11g cosine 30. As before, Wx is also 11g sine 30. So this is the gist of it. Now let's get to the meaty part. Well, again, look at the question. We want to find the minimum force that would just about slide the box upward along the plane. Hence, what is this friction? Is it static or kinetic? This again would be static because we are just at the point of moving it up, but not really quite there yet. That would give me my minimum force required. That would be at the point when friction is doing all that it can to stop me from sliding the box up along the plane. Hence, friction would be static, and moreover, just like B, friction would be at its maximum value. So since there is no motion in the y direction, we can write down Newton's second law in the y direction quite simply as n is just equal to the y component of weight, which is 11g cosine 30, right? In the x direction, what do we have? Again, you are just about to slide it up, so you are not quite there yet, hence acceleration is 0, right? So what are the summation of forces? We have F me in the negative x direction, so negative F me. We have Fs now pointing along the positive x direction, so plus Fs, and we have Wx pointing along the positive x direction, so plus Wx. This is equal to 0. So negative F me is, let's take everything else on the other side, is equal to negative Wx negative Fs. This is our, let's call it this, let's call this equation 1, let's call this equation 2. And then, as we know by now, the maximum value of the static friction is when static friction is equal to mu s times n, which is mu s is 0.4 times 11 times 9.8 cosine 30. This gives me the static friction as 37.3 newtons. This is the maximum value of static friction which I would have to overcome to move, to just about slide it up the plane. That would give me the minimum force. All right. So now that we have found static friction as Fs is equal to 37.3 Newton, we just plug that in to equation 2 to solve for F me. So we have negative F me is equal to Wx is just the x component of the weight, which is 11g times sine 30. 11 times 9.8 is a negative here, sine 30 minus Fs minus 37.3. all right. Then since all of these terms are negative, you can multiply both sides by negative 1 or divide both sides by negative 1. It doesn't matter. Will help me solve for F me. So this comes out to be 91.2 newtons. So this is the minimum force that I would need to exert to just about move the box up the plane.